Gentlemen, it's my privilege to introduce our distinguished speaker for this session, Mr. Shreyas Hegde, Principal Enterprise Architect at Prudential PLC, India Health. Mr. Hegde is leading the design and execution of a transformative data first platform that integrates the entire health insurance value chain from policy administration and CRM to claims and customer engagement. His mission is to architect scalable AI enabled ecosystems that deliver measurable value while enhancing healthcare accessibility and efficiency. With a strong passion for the convergence of AI and healthcare, Mr. Hegde is redefining how insurers assess morbidity risks, automate decision making, and deliver personalized patient centric services. His contributions align closely with Sustainable Development Goal 3, good health and well being, as his work focuses on improving healthcare outcomes, enabling preventive care through predictive analysis, and making healthcare delivery more inclusive and effective. He has also contributed to the research community with publications on topics such as cancer risk prediction from genomic data, advanced deep learning architectures for contextual understanding, and hybrid models for sentiment analysis in public policy. Alongside his technical expertise, Mr. Hegde brings strategic leadership, managing partnerships, cost effective technology adoption, and fostering innovation driven teams. As a part of this FDP, Mr. Hegde will be delivering sessions on machine learning for healthcare analytics SDG 3 and a demonstration on machine learning applications for healthcare. Where participants will gain insights into how AI and data analytics can revolutionize health systems to better serve society. We are delighted to have him with us today, and I warmly welcome Mr. Shreyas Hegde, who is also our proud alumna of Batch 2013, to share his expertise with our participants. Over to you, sir.
Thanks for the introduction. I think without much delay, let me start sharing my screen. Um, just a minute. Right, hope the screen is visible.
Yes, sir.
Sure. All right. So, uh, thanks for the introduction. I'll not spend much time on this. Um, for today's session, what was there on my mind is around healthcare analytics, specifically how it's growing for the India region, right? And the evolution that we are all seeing from machine learning to generative AI, right? So how does it encompass it all? I'd encourage participation. Feel free to stop me anytime and ask any questions. I'll send over the screens later. Um, so just a quick intro around where we are in healthcare, right? Uh, so basically, the world that we lived in looked at healthcare more as a reactive event, right? Whenever there was an event, we went into a hypercare stage, looking at what do we do with that healthcare event, right? And given India is a uh, big healthcare market also, just wanted to take this time to walk through how the landscape is changing, try a mix of theory with practical experiences that I had, and how do we share, right? I mean, just a fun fact. I think India is the diabetes hub of the world, right? So we need it now more than ever. Uh, there are a lot of startups in this space. There are a lot of government initiatives. So we'll just look at those one by one. Um, in general, uh, healthcare is becoming more and more data oriented and data focuses with the big players stepping in, right? The big players like Microsoft and Google taking a special focus towards healthcare, and how AI and analytics is uh, changing all of those. So specifically, when we look at the Indian context, um, so the government did come up with a platform called eSanjeevani. I think till date it has done more than 15 crore consultations. It had more than 15 crore consultations on the platform. So given that scale of India, we could all imagine the role technology, especially AI, plays uh, in the Indian market. And I'm sure everybody of us prefers a fitness band, right? Or a fitness watch over a normal watch these days. Um, and how all of that come into play in real time. So typically looking at an overview of how generally the healthcare landscape is moving in India, right? So as I mentioned, so we have moved out from a typical traditional analytics to more machine learning and deep learning sort of analytics, right? While machine learning focuses uh, a lot on decision making based on the patterns it recognizes, right? So to do that, the first thing that's essential for anyone is to have have a data set, and that's the hardest part of any machine learning problem, right? So uh, there's a general saying that any machine learning engineer spends 95% of his time cleansing the data and 5% of his time building algorithms, right? So that's the importance of data and how do we manage data. uh, Again, this was one of the interesting case studies. I'm not sure if you have come across this. So uh, there's this Chennai based hospital called Arvind Hospital who, so I mean, a decade back started collecting the retinal images, and they did come up with a retinopathy detection for diabetes. I mean, this was a decade ago, right? So the crazy or the fancy part of it is not identification of diabetic retinopathy, but recently, I think a year back, Arvind Eye Hospital established a connection between retina and the heart diseases, right? So basically, they came up with an algorithm which proved that there's a direct linkage between eyes and the cardiovascular health of a human. And that was only possible because they started collecting this data 20 years back. Uh, so typically, machine learning helps us with a lot of pattern detection, unknown pattern detection, which, I mean, it was a new discovery even to the medical field because doctors did not think there could be a relationship between eye and the cardiovascular health of a human, which was pretty much identified by those guys sitting in a eye hospital in Chennai, right? Uh, but given that not all of us, not all companies, not all individuals are are lucky to have such data sets, which is why we are leveraging more towards generative AI, right? Where a base model is provided by a large corporate, which typically has all this data sets with them, right? So one of the examples of a generative AI is where you could typically do a lot of you can do a lot of categorizations, classifications, You can create synthetic images, right, without the need of having data. And essentially, we as individuals or as a firm, right, can build wrappers on top of this, a new concept called agentic AI, right? So I'll not deep dive into it, but the new concepts of agentic AI, where you know uh, we can basically leverage the existing data to do a lot of analysis on the healthcare. I'll just stop my screen sharing for a bit and show you a couple of interesting things, right? With um, hope my screen is still visible. Um, so let's take a couple of examples for that, right? So I did have a couple of images which could basically help us understand why or the importance of having this, right? So let's take this bill, a medical bill, typically notorious for any human to understand, right? I mean, uh, it's a mix of Hindi, it's a mix of English plus given doctor's handwritings, which we all read for. How do we understand what's happening? So let's look at typical agent at work. So we have something called as an agentic AI, and let me just add that bill and ask it to explain what is written in the bill, the medical prescription, summarize it in English for me. Let's just look at it in action in real time and see how it works. So you can see this. So this is a concept of explainable AI, right? Where the agent is essentially telling me what it's doing, how it's visualizing my bill, what are the codes it's running behind the hood to make my use case come to life, right? So it's basically now explaining me all these things in real time. So it says live, right? Which means the agent is active in real time and showing me all the details. So given the bad quality of the image, it's even automatically scrolling the image to uh, for a higher zoom ratio, right? Scrolling through identifying the details. Let's just see what it gives us. By the way, this is a random prescription I picked out of the internet. So as the agent works its magic, happy to answer any questions upfront if they are there, or anything at this point. I'll just take a pause. Happy to answer any doubts or queries. Let's just Uh, Sorry, was there a question?
If participants are having any queries, please post your queries on the chat box.
I would definitely like it to be more engaging, so
Yeah.
please feel free to ask any queries. Right.
Okay. By the way, what kind of explainable AI is being used in this agentic AI?
So this is
Interpretable or?
yeah, this is a new kind of a model called as XAI,
Mm.
which the GPT-5 uses, right? So it's a custom open AI model that
Okay.
is used for explainability. Basically, this is agentic AI, not truly generative AI, which is where we see it zooming into images. Took 4 minutes, but it did give out a decent explanation, including what the consultation slip was about, right? Where did it come from? So the patient details, then the diagnosis and the recommended tests, right? And a summary of the bill document. So it says it's a medical consultation slip, suspected of hernia, right? So this is one of the cool features of the new agentic AI. Let me just demonstrate another thing. I did have an X-ray image,
Mm.
right? So what we typically did a couple of years back was we needed to have a lot of training data, right? So we talk about multimodal in the current world. What does multimodal truly mean is that it can respond to text, audio, videos, any type of modes. So essentially, what we did with one agent is that we provided it a form data, which is typically OCR in nature, and we also provided it a second is an X-ray image, right? And it does handle multiple modes without switching the context, and it's giving a detail of this version. So as we look at this here, says appears to be a chest X-ray showing upper part of the spine. No obvious signs of fractures or dislocations, right? Uh, and it also adds a caveat saying that only a radiologist or a qualified doctor can provide accurate diagnosis. So, so this is one of the parts where typically we see a lot of agentic AI in the modern day without the need of training data sets. Let me go back to my slides, which is where generative AI comes in, right? So typically, how do we place it is a machine learning model generally predicts, a generative AI generally creates. With a newer kind of agentic AI that we just saw, it both predicts and creates. Again, a basic slide um, created of supervised created of the types of machine learning generally. Three of these majorly are used in healthcare: supervised, unsupervised, and reinforcements. And generally, as per my experience, the most simplest model is the best. I mean, I've never seen a logistic regression outperform deep learning model in a true sense until and unless we have tons of data, right? You do see the spelling gone wrong, because this was the whole context of why the spelling went wrong is because the entire slide was generated by an agentic AI for me. The entire set of slides that you see on the screen. Right. So again, when we get into a bit more specifics about generative AI, right? So it we just saw that it can basically analyze your data sets, but uh, the next question that we have is, can it create new realistic data images, right? Um, which it truly does, not just the text. Let's get into a bit of discovery around that. Um, it can basically learn your underlying distribution data if you have any, or even if you do not have, you can then create your own data points. I mean, one of the real-time examples is a company called Insilio Medicine in US, generated a fibrosis drug within 18 months. I mean, less than 18 months, purely just by using a generative AI, right? And we have medical imaging, which are pretty common these days. We did see an example of medical imaging. We saw personalized medicines, creation of treatment plans based on patient specific data, right? So we did give it a medical bill and we asked it what the diagnosis is. We could take it a step further and ask what are the treatments that it needs to have. Let's get back to our agent for a minute and ask it to, we talked here, what we saw was analysis part, right? So can it create sample chest x-rays for detecting? So it does create a lot of synthetic data for you, which is where uh, which is where a lot of which is where the world is basically headed, because nobody has the entire gamut of data sets, right? So it picks up the context well here because I did give it a chest x-ray image before that. And once we ask it to create sample x-ray data sets, it starts thinking about, it starts looking at my uh, single x-ray provided, and it starts creating a lot of sample data sets. Again, we'll just hold back for a minute um, to see if there are any queries. Yeah. Hi, Rahul. I think you did have a valid point on how do you validate the data, right? So two-part answers to that. Um, so first is, let me before we validating the data, right? Let me try and explain how does a Gen AI or a generative AI or any sort of machine learning algorithms get these data, right? So uh, it's there in my upcoming slides on India specific, but in general, the generative AIs are trained on something called as an FHIR, which is a huge set of database, right? So it has tons of data uh, with your basically your care plans, consultations, the diagnosis, the prescriptions. So generally the data is validated from there. And when it comes to, so generative AI doesn't ground data, right? It generates data. Uh, there's a session later planned on how can we create one of our own agents, where I planned to show all of you how do we ground the data. So there is a concept called as data stores in generative AI where you can essentially ground your data. So let me try to show one of that. Okay, so if you look at something on the right side here, if my screen is clearly visible, right? So you see two options with, so this is a collection of all the data, all the models that you can have. So this is my project where I do have a lot of models onboarded. So here you see an option of grounding, right? Where you can either ground with your Google search or you can ground with your own data. So these data typically you can feed your own data sets to it as a part of RAG, Vertex, and Elastic. The beauty of this is that you move away from a deterministic kind of uh, prediction. By deterministic, what I mean is typically in machine learning, what we do is we look at the data and the algorithms determine the next sequence of steps, right? Because the only thing it has seen is your data. But with generative AI, you get more into a non-deterministic flow because the underneath algorithms that the generative AI typically has already seen a lot of FHIR data. Uh, but then it uses that information to customize it for your own RAG engine that you can build. And that is how a lot of your data is truly grounded. The outputs are truly grounded. Again, when I was talking about FHIR, right? So there is something called as an FHIR viewer. Um, if I last remember, it did have over 50 terabytes of data, which uh, which the generative AIs already use. So, which is where most of its intelligence comes from, specifically in the healthcare domain. All right. So, if you look at this, it did create a lot of synthetic data for you, right? Including the chest X-rays. The first one was a chest X-ray with a patchy opacity in the upper right lung. The second is a bilateral pattern, right? So you can in real time create a lot of synthetic data based on the data set you have. I mean, I've just provided one image here, but imagine if you had GBs of data, you could truly create synthetic data for your algorithms to build and run better. Hope I did answer your question, Rahul. Just getting back to the slides. Okay, so this is a new development that is not yet GA. By GA, I mean generally available. But there is a model already in research labs, and luckily I do have an access to it. I hope I can demonstrate it to you later. But what this is being developed by Google Deep Learning Labs. What Google Deep Learning is doing is they are building a model called as MedGemma, which essentially has taken the entire data set that the universe could have, right? It has radiology data sets, dermatology, pathology, FHIR, medical text, and is building a medical only model with almost 27 billion parameters. It can do image classification, it can do text classification. It's truly multimodal in nature. So this is one of the examples that that put out, right? Especially the rightmost one, if you see, it's a the image is a detailed image of a human skin, right? And it was able to predict whether it was able to basically predict whether the skin, I mean, there was malignancy in the skin. So this model has been clinically proved to have an accuracy of 81%. So that so the results are not yet out, but these are being tested in the labs, and um, this potentially is a game changer for a lot of organizations who are in the healthcare world, obviously, but not just healthcare, the insurance world, the finance world, right? So what essentially where essentially the world is moving is when banks or insurers typically gave out an insurance or a loan to you, they just looked at your what we call as a CIBIL score, right? But pretty soon, I'm pretty sure that very soon the banks are starting to look at your health score or the medical score. So just by your facial images or a certain there are fancy ways that corporates collect data. They ask you to upload a selfie for your matching and all of those stuff, right? But essentially, what they will start doing behind the scenes is start looking at your mortality or morbidity scores. The difference between the two is mortality is a prediction of your lifeline, basically, and morbidity is the prediction of a chronic condition that can come up. Um, so insurers have been using this a lot in underwriting, uh, on how they underwrite a policy. Uh, banks pretty much will start using this as your personal health score combined with a CIBIL score to basically issue loans. See a chat. Okay, so yes, an interesting question. Have I seen a, thanks Rahul again, have I seen a bias? Uh, Absolutely. And in reality, 80% of the outputs have bias. More than 80% of the outputs have bias. Um, the way to solve that uh, is again a two-bit answer. Sorry for not keeping it short. But if you're looking at a custom machine learning model, the data sets are pretty much yours, right? So the bias comes from, there are various types of bias. It could be a data bias, it could be an algorithmic bias, it could essentially just be a drift bias, right? By drift bias, uh, we mean that a person living in a tier 3 city, right? Assume a small village who eats and breathes healthy things, who breathes fresh air, who eats good food, has suddenly got a job in a tier 1 or a tier 2 city, right? So imagine a person from a small village moving to Bangalore. So essentially, there is nothing wrong with your algorithm or with your data, but just because now the person has shifted geographies, uh, there's a bias, right? His mortality and morbidity score suddenly changes. So that is something that we call as drift bias, which we see a lot with the Indian population, given that people relocate between geographies. But apart from that, if we are typically looking at data bias is the easier one to solve because you know what data you have. Algorithmic bias is a bit different, which is where governance and monitoring comes into play. So um, there's a lot of strict governance that happens, especially on the AI bit. So this is purely on the machine learning side. Now, generative AI side, how big techs have solved bias is um, they give you an option for deployment, right? When you deploy a particular model, you see a lot of endpoints, and the likes of Google and uh, Microsoft or OpenAI, what we use as general customers is a generic AI. But if we start using specific deployments, right, as a company, I mean, as a machine learning engineer in India, if I want to deploy a Gemini model in India, right? So Google provides endpoints for India, which means under the hood, it starts training based on India data. Again, I could just show you an example for that. So we were talking about MedGemma. Let us look at MedGemma itself. If I go to my model garden, I search for MedGemma, right? And it's the model that we just talked about recently. One is you can try it out directly from here. The other one is that it gives you deployment option. So let's say when I want to deploy it, I'm asked for a region where I want to deploy it. So generally, when we deploy it in India, there are two regions supported, Mumbai and Delhi. As soon as you typically start deploying it in an India region behind the hoods, a large language model typically starts using Indian endpoint to train this. So which is how a lot of big techs solve the bias for data. So usually, usually a bias is a mistake by a developer where I end up deploying a wrong model in a wrong location, right? If I am using a generative AI model, if it's a pure play machine learning model, then the three types of bias that I typically told you holds true. Long answer, but hope that was a satisfactory one. So we were talking about some frameworks, right? So I'll probably post the links for these frameworks, but to have ethical and governable AI, we do have a lot of frameworks. So CRISP DM is a cross-industry standard. So basically, it's not just for healthcare, but how healthcare data is used in other in other domains, right, or other industries. And then Microsoft has come up with a AI framework which offers guidance, proxies, responsible AI solutions, ethical AI. Google is pretty big on healthcare again. Google have come up with their own framework for healthcare. This is I mean, you can just search for Google Healthcare AI and you should be able to read all about it, right? So Google has a big domain of health AI. Essentially, what they are doing is they are trying to bring in frameworks uh, for responsible use of healthcare AI. It's an interesting page. I would recommend everyone to just look into Google's health AI. Right. So again, to your point, um, so on how unfair biases are avoided, right? So which typically all big companies work under a framework to make sure that the bias is reduced. So stepping a bit into India specific context now, one of I mean these are the two big missions that India has started, right? The Ayushman Bharat Digital Mission and ABHA, which is our Ayushman Bharat health account. So Ayushman Bharat digital mission, essentially what the government is trying to do is government is trying to bring. So there are so to I mean, if you look at a healthcare ecosystem, typically there are three players, right? Or it has three facets to it. One is the customer itself, one is the payer, and the other is the provider. By payer, I mean uh, if let's say I am the customer, right? Or I mean I'm using customer loosely here, but typically if I am the patient, right? So I could have two payers, right? One could be my family, the other could be an insurance that I carry. So these are typically called as players. The third is a provider. By a provider, which typically mean a hospital, right? Which treats you. So what Ayushman Bharat Digital Mission is trying to do is bring all payers and providers on one platform, so that there is clarity of I mean there's a governance clarity and typically reduces fraud. So at one point we are looking at, I mean, from one perspective we are looking at building healthcare and AI, right? But this also leads to a lot of what we call as FWA, which are three letters. So F is fraud, W is waste, and A is abuse, right? I mean, the differences between those three is fraud is where I'm basically committing a fraud, it's a wrongdoing. A waste is where I could have, treated myself in 100 rupees, but I treated myself in 150, 200 rupees, right? Where um from a government's perspective, there's a loss of economy, right? Or a lot of potential waste these days are that uh, typically Indians go abroad for a treatment, right? You see that a lot with celebrities, especially, which sort of is categorized as a waste because that could have worked for the Indian economy, but it did not, because the payer and provider were not on the same platform, which is where India is trying to bring all these guys onto one platform. And interestingly enough, they have also exposed their APIs. So anybody interested can, just talk to ABDM, get a sandbox account, and start integrating with this. So Ayushman Bharat Health Account is like a is basically a unique health ID. What government is trying to do is give everybody ID. Um, so just like we recognize a person from his PAN number or his Aadhaar number, a provider, a hospital should be able to recognize a citizen by his uh, ABA ID. What is the coverage for hospitals in this data interchange? All government plus private hospitals. Yes. So government, I mean, the Indian government as a part of this mission is trying to get all providers on board. So there could be smaller clinics which are eliminated, right? But it's getting both government hospitals and private hospitals onto this platform. Plus, it's getting all the insurers onto the platform. So essentially, what it wants to do is have all payers and providers at the same place. Um, the benefit of it is that there's a centralized, so the triaging becomes better, right? So just like we saw with the rush of COVID and people didn't know where to go for what. Um, so this brings a sanity amongst all providers, meaning I don't have to wait at a particular place at a particular hospital for a long time if there's a alternative available. And it's trying to cut down on all the fraud, waste, and abuse that happens. I mean, you go to a hospital, get treated, but you claim from two payers, right? Because you have two different insurances, you claim both those insurances, and the insurers typically end up wasting a lot of money. So, which is where the government is trying to first centralize all providers, second, eliminate any fraud, waste, abuse that happens. Interestingly enough, on the interoperability question, yes. So there is a standard format that is being developed, which is called as Accord. Uh, so FHIR is for all the health related standards, but the standard interoperability mode between these providers is now becoming something called as an Accord, uh, which is which is typically a health domain driven data model, and even the API endpoints that are being exposed from all these national platforms come under those. So there's a standardized format that's, so just like we had REST for APIs, so there is something called as Accord for all health related interoperability of data. Again, one of the crucial things, so India was not big on data privacy and protection, but given the latest changes that we saw, one of the good bills that was passed is the DPDP, which is the data protection bills, right? So, which means there is now now careful governance on what we call as a PHI, personal health identifier, right? So uh, each one of us owns our own health. So until and unless I don't want to share my health data with anyone, I should not be forced, right? But typically in India, given the landscape, we didn't have much controls over how health information was being shared with each other, right? I mean, you can see, I mean, if you had visited a lab a couple of years back, you could see endless SMS and notifications coming from all of these guys, right? To get tested again, or let's say if you had diabetes, you would start getting messages from the likes of Apollo, MedPlus, or all these pharmas. So providers used to share this data, which is now strictly banned. So the DPDP that way is bringing in a lot of governance on how personal data is being protected in the AI era. And DPDP also applies to all AI models. So any AI or healthcare model in India now should uh, be a part of this bill. So getting back to a bit around our on how a typical pipeline is developed or deployed in healthcare, nothing changes from how we deploy a normal machine learning model. The only difference is that in data collections, right now with ABDM coming in and FHIR plus, government is building something called as a EHR vault, electronic health records, where it basically anonymizes data and provides a lot of electronic health records. Data is coming in from wearable devices, images, right? So the standard steps of collection, then it's pre-processed, then the feature training happens, model is trained, model is evaluated and deployed. I think I did miss a few points here, which is a feedback loop. So typically a machine learning model should have a feedback loop which feeds the data, I mean, which feeds the acknowledgement essentially back into the original model and keeps upskilling itself. Yeah, again, so some of the cool use cases that are currently being undertaken is on the drug discovery. especially on the genomics side. So genomics is a big area where a lot of healthcare research is happening. Uh, so typically, how do we predict morbidity? So morbidity is how somebody or how and when somebody gets sick, right? Typically, morbidity was predicted based on the clustering algorithms. So it's either KNN or deep learning clustering models, right? Where we said that I have 50 dimensions. If someone matches these 50 dimensions, I put him at a high risk of morbidity, right? But the scientists and the machine learning enthusiasts have taken it a bit further and are doing a lot of discovery on genomics or molecule structures. Basically, is a human is a human's molecule structure uh, a good data set to predict what would happen, right? So essentially, what that means is we could have morbidity scores for children as young as 2 years or 1 year, right? Both a boon and a bane, I would say. The boon uh, is that typically there are a lot of malnutrition children, and governments can do a better job in predicting and taking care of those. The bane is that the financial institutes and the insurers start exposing or exploiting that information, right? And your cost of living just goes up crazy. um, Again, personalized medicines, so specific plans based on specific data such as genomes, lifestyles, medical histories, medical imaging. Medical imaging has become pretty common. uh, another a smart set of virtual assistants coming up. So Apollo does have a AI nurse chat for chronic care management. And so these are some of the use cases that we could have. uh, so the last one that we saw, virtual assistant, so in the hands-on session planned, so let's build a virtual assistant. Let's look at how easy it's to build a virtual assistant. So again, some of the latest and the greatest generative AI models that are out there: GPT, Claude, Gemini, Mistral, Llama, MedPalm. Right, MedPalm is a series of Google's medical AI models. So MedPalm is pretty interesting. MedGamma uh, is a inherited or a child model of MedPalm. So these are some of the challenges. We could call it risks or challenges where there are ethical considerations. We talked about bias. We talked about data security. We talked about lack of interoperability, right? So how do providers or how do patients, how do payers exchange information between each other? Good to see that uh, there is a lot of work and emphasis done in India in all these three. There are also a lot of regulatory changes coming in. Uh, so currently it's still a gray area. We do not have strong regulations around AI in healthcare, but hopefully we would get that pretty soon. Again, so uh, I'll not go through the details of this, but one of the important points is the human oversight, right? So typically, what we call it as HITL, human in the loop. Any AI healthcare model uh, should have a human in the loop. An AI model currently is not at a stage where it can make automated decisions, right? It's a assistant to you. It assists you, but the decision making responsibility should lie with an individual, which is where we call human in the loop or human oversight, basically validate the decision that's taken by a AI model. Again, some of the reference architectures on how hospitals, providers, large companies are interacting with each other. This could be an interesting topic. We could delve deep into it, but one of the one of the pretty common mistakes that I see in a lot of corporates are, while there is Gen AI, we do not know how to really extract the best value of that, right? We do not know how to create prompts, or essentially what is called as prompt engineering. So one of the interesting things that could be picked up by us as educators is really uh, teach our peers, teach our students, right, on how to effectively make use of prompts so that we extract the best out of any Gen AI model. Uh, then have uh, have a clear view of what the policies are, how the data is governed, both from ethical or regulatory aspects. Uh, there are a lot of publicly available data sets. How can we empower someone, right, with all these data sets? And then the world of healthcare is moving pretty fast. So, what are the different case studies that we could provide on the implementations? How do we focus on outcomes? How do we focus on failures? How do we learn our lessons from a case failure? These are some of the latest successful implementations that have happened. There's a Microsoft AI Diagnostic Orchestrator. I have added all the links. I'll share the PPT in the end. Maybe you could go through this in detail. Uh, so there is a AI equipped imaging tool in AIMS Patna, which is uh, you know empowering doctors with early detection, customized treatment plans. Then ADOC has created a FDA cleared algorithm for image triaging, right? Which a lot of these generative AIs typically end up using. These are some of the real world examples of various companies getting into generative AI and what they have been specifically doing. I'll not go through this in detail. The information is there on the slide. Again, for personalized medicines, who has been doing what? So based on your genetics, medical history, lifestyle, how do we optimize the drug type, dosages? What are the precision medicines, especially for autoimmune conditions? Cardiac intervention, how do we create digital twins, right? From basically move from a reactive event to a proactive monitored event. uh, apple apple is doing a is Apple is doing a big job, especially on the digital twin. Apple it's in the incognito stage for now, but Apple is coming up with a sub company called as Apple Healthcare. So one of their big talking points is on the cardiac intervention. Awesome. I think we have reached the end of the session. Any specific questions? Happy to help, or we can. I'll just hold on for a minute. Any specific questions? Please do feel free to ask in chat. Sure, I'll do share the PPT post the session. So, uh, Dr. Sampata, how do we proceed next? Do we take a quick 5-minute break?
Uh, sure, we can take. Not an issue.
Sure,
We can join by 7:45, I guess.
sure. So
Huh?
we'll just take a quick break and let's get some of our hands dirty into building an AI application.
Yeah,
Looking
sure.
forward to it. Sure.
Yeah. Participants, we can join the session within next 5 minutes. You can take a small gap here, and following session will be like a demonstration or hands-on session with Shreyas. Yeah, thank you. Hello.
Yeah, hi. I'm
Yeah.
good to begin when everyone is ready.
Yeah. I think we can continue with the next session, I guess. So I welcome all the participants for this second session, wherein we will be holding the hands-on or demonstration session of whatever the theoretical concept that so far Mr. Shreyas have discussed upon. Yeah. Thank you, Shreyas.
Sure. Thank you. Okay, so let me just share my screen. My screen is visible.
Yes.
So what we will do is we will build an agentic AI which answers our questions. So let's see how quickly we can build an agentic AI which can solve our purpose. Just so what we are going to do in the session is let's have this main agent which we call as steering, and let's have sub agents. One agent that answers any questions on Ayurveda, let's say. The other agent which talks about diagnostics. The agent which talks about health and well-being. Then a symptom checker. And this agent routing a customer's query to particular sub agents. Right, so let's see how we can build this in real time very quickly. So I'm using something called as conversational agents, which is available on the Google Cloud platform. So let's start creating our agents. So uh, so what I'll do is I think Rahul had an interesting question about how do we basically ground data. So let me also show that. So what I have done is I have a Word document about which talks about Ayurveda basically, right? And we will have one agent just talk about this and is grounded. So let me up. Let me upload. I've created a bucket where I'll upload that file. Okay. And we have something called as conversational agents. And let's see how quickly we can build a agent in real time, right? So I'll build my own agent. Let me say it. 19th. Choose global. And we can create either a flow based or a playbook based, right? A flow based is deterministic in nature, where we are giving it a set of steps. An agent based is where it's real time. Let me create a playbook based so that a generative AI can understand my intents. All right. So this is something which is an agent interface. And what I want to show you today is how we can create AI agents without writing a single line of code, right? Um, I mean, we can choose to write codes, but even without codes, how can we just give instructions and create agents? So first thing is it has something called as tools, right? So here we can create a tool. Basically, a tool is a set of, let me show you. A tool is something where we can connect an API or a data store or a function or a connector. So in this case, what we are trying to do is so the Ayurvedic agent only looks at the Ayurveda uh, file, right? And does not, and is 100% grounded and does not use internet information. So let me use this. Let me give my agent a name. I'll call this Ayurvedic guidelines. Oops. Got this Ayurvedic guidelines data store. Let me create a new data store from my storage. Um, time. Let me browse the file that I recently uploaded. So remember, our end goal is to create all these agents, right? And have just one interface which can do all these things. So just like a few moments back, we saw ChatGPT agent doing anything. So this, let's call this as our custom agent. So I have just started training it on my custom data now. Let's go and create some playbooks. So I'll just hit a save. So let's come to the default or the steering routine in the end, but let's start creating some simple playbooks, right? So what I'll do is first, let me just have this and then explain how it's done. So I'm giving my agent a name. I'm giving agent a goal. Let me just explain this, and I am giving it a set of instructions. Okay. So if you look at this agent, we are building an Ayurvedic agent, right? So what I did is I just gave my agent a name. I'm calling it a Ayurvedic guidelines expert. Its goal is to provide precise information exclusively from this document, right? And it is acting as a focused authoritative knowledge of source for Ayurvedic medicine, meaning this particular agent is completely grounded. It does not use internet information. I'm giving it instructions which say that upon being routed to this agent, acknowledge users' interest in Ayurvedic treatments, right? And then the agent's sole source of information is the book or the Word document that I give it. It will not refer to any other document, right? Information retrieval. So what I'm doing is instead of coding, I'm giving it a step of sequence. It's like writing a pseudo code, right? So before we actually start coding, we write pseudo codes, algorithms in a sequential manner. So what I'm saying to this agent is I'm saying that you are an Ayurvedic agent who just refers to the Word document I uploaded. Whenever a customer asks a question, symptoms or treatments, you have to use this tool to search for relevant information. So if you see, this was the tool that we just created in tools, right? With this information. And I'm saying it that you should present the retrieved information directly. I'm giving it more instructions where I'm saying it if you have multiple results, present them clearly to the user. For example, I found information on topic A and topic B. Which do you want to explore first? So instead of coding a lot of if-else conditions, I'm giving it clear informations. And I'm also telling it what are out of scope queries. So for example, if a customer asks about topics not covered by the document, then you should politely redirect saying that your capabilities are limited to the Ayurvedic information. Right? So this is how we now created a Ayurvedic agent. So let me just save this. So let's go on to create our next agent, which is our generative healthcare AI agent. So what I'm doing here is, again, I'm providing it a goal. Let's look at this agent now. So now this agent is specifically uh, is specifically an agent which provides educational information about AI's role in modern healthcare. So it looks at various domains: research, diagnosis, treatments, regulations, ethics, and provides information. But I've clearly told it that it should not provide medical advice. Its job is to just provide a specific information. So think of all these agents as microservices in the technology world, right? So each agent I'm building is to do one job and only one job. So we built an Ayurvedic agent which just talks about Ayurveda. We built a general healthcare information agent which just talks about information. For example, I say that your scope is to provide information about AI applications in healthcare, including research, diagnosis, treatment, and ethical consideration. No medical advice, right? And it just provides information on explain AI's role in image analysis, how AI can be used, discuss AI's role in drug discovery, right? Explain how AI accelerates medical research and pattern identification. Summarize key results, FDA, EMA, ethical concerns. And if suddenly somebody asks you about Ayurveda, then you should say that you are not the Ayurvedic agent, right? And it has to redirect to the other agent that we created. So again, now we have built our second agent. These are called as playbooks. Let me now create our third agent. This is a medical diagnosis agent, the one who diagnoses condition. So here again, to this agent, I'm giving a set of instructions. I'm saying that this agent is to educate users about general principles of medical diagnosis and how AI is applied in diagnostic processes. Again, refraining from providing medical diagnosis. So this talks about how medical diagnoses are generally made and how AI assists in this process, right? So I'm describing the steps involved in diagnosis. So gather patient's history, conduct physical examination, utilizing diagnostic tests, right? And AI's role in diagnosis. So how AI is helping in diagnosis. I'm asking it to provide general examples if a user asks with specific patient data and redirection. So if anybody wants to talk to an Ayurvedic expert, just redirect to our Ayurvedic guide. Or for specific medical advice, please consult a doctor. I can only offer general information about diagnostic processes. Right? So we did this. let's now build a treatment options explorer. So this explains about how treatments can be undertaken. So similar to our previous models, previous agents, sorry, we are again giving this a set of instructions on how to use a treatment options explorer. So this is for anyone looking for exploring agents, right? And now let us look at a patient care advisor. So now I'm building a patient care advisor which provides guidance on patient care practices. And similarly, I'm adding instructions. So now we have created all the sub or the child agents. We have to create a steering agent. So let me explain what the steering agent does. So a steering agent, what I have asked the steering agent to do is, it talks to the customer, it understands the customer's initial query, right? So based on its initial query, it redirects it to custom agents that we just built. So if the customer expresses interest in Ayurvedic treatments, redirect him to the Ayurvedic agent. If customer inquires about general AI applications in healthcare, redirect him to healthcare AI. If customer asks about symptoms, route him to medical diagnosis assistance. Right? If customer asks about treatment options for medical conditions, route them to this. So similarly, this is how we have uh, similarly, this is how I have given a if-else condition saying that based on a user's intent, redirect them to the specific AI agents, right? Let us just save that. There is something called as an agent overview here. Now you can see how each agents are linked to each other. We just have one level of agents, but we could have multiple sub agents, right? So this is the first agent that gets called, and based on a user's intent, will detect any of this sub agents that we call. So let us now start talking to our agent and let's see how it behaves. Right. So we are simulating an agent now. So all I will just say is I'll say a hi. And I've asked it is basically asking me, how can I help you today? I'll say, what can you help me with? Right. And let's see how it behaves. So it states all the sub agents that it has. So let me just ask it. I want to understand more about patient care. Okay. So this is how now the our main agent invoked a sub agent, right? So we had built 6 agents that we saw here in the agent overview. Let me again show you that graph. Right, this is the entire model that we now built. So if you see here, we had this agent, right? And this agent now invoked the wellness advisor agent, and it says, I understand you are interested in patient care. I can provide more information, right? In terms of patient care and support, also says, for example, now let me say, I seem to be having high BP. What cares and caution right, consider. You see, we have not built in a personalized plan because we have asked it not to specifically uh, give any healthcare advices, right? But let's say now I want personal advice, right? So let's add a new playbook for personal advice. We just saw an illustration of how we had built an agent which gives general information but does not give personalized wellness plans or health concerns, right? So let us call this agent a personalized health planner. And I'll say your goal is to create personalized health planner based on a user's health condition. And I will ask it, greet the user and ask how is he feeling today. Then ask specific questions about his condition. For example, if he has maybe ask further questions related to BP. Let me add one more condition where I say if customer has diabetes, ask him further questions including HbA1c range, and I'll add a sub if condition, which is once you confirm with the user that all questions have been answered, offer him the best advice for diabetes, right? So we just built this new agent called personalized health planner. Let's go to our main steering agent and add a new condition saying that if the customer is looking for personal health advice for his conditions slash care slash planner for his health for his conditions, route him to add this, right? Add this agent that we just created. Let me just hit a save. What is the error that I'm getting? Instruction. Use playbook. So I've just added the personalized health planner playbook here. Let me hit a save. It has saved. Let us look at our graph again and see if we have got that agent connected. Right, we have got the new agent connected here. So let's test that guy now. Personal health advice. And you can see that it called our new agent, right? And it is asking me how am I feeling today. Let me just say I am feeling nauseous, probably because of my diabetes. So remember, this is an agent which is now not just giving me medical advice, but is which is not just giving information, but is giving me medical advice, right? We just built this guy with 4 lines here. It's asking what type of diabetes do you have? Let's say type 1. Let's see if it, let's use a voice. I have type 1 diabetes. My recent HbA1c readings were 7. I'm not taking any medicines as of now. I have a bad case of nausea today, and it has never been there before. Uh, I'm a bit cold feet, besides nausea. And let us see how it behaves. I hope it did recognize my voice. It did. Okay. So look at it giving out clear informations now, right? Given that you have type 1 diabetes, nausea and cold feet, especially in someone with, can sometimes be more serious condition like a diabetic which requires immediate attention, right? So now I don't know what this term is. Let me ask this guy to a layman who does not understand medical terms, right? And you look at how easily it explains, the concept in terms of a layman. Let's try to switch languages. I haven't tried this, but you see, it is currently only built for English, which is why it's explaining in English. Let me ask it stupid questions which are not medically related, and let's see how it behaves. Can you book and book a flight ticket for me? You see, it's saying that it can understand and generate text in multiple languages, but primary function is to complete tasks in English. And because we were in between a medical term, it clearly said that it cannot book flight tickets, right? Because the agent is only built to explain the medical tickets for it. So let me say, explain diabetes to me in Hindi text. Apologize, but I cannot provide medical explanations in Hindi. Current capabilities are just English. So we can add those capabilities in settings. But any queries till here? Any doubts? Just wait for a couple of minutes. If there are any chats. Where did it go? Okay, so I see a message. Hey Priyanka, I did see your message for genomic data prediction. Let me get back to you in some time. But any queries on how easily we could build an agent? Right now, let's try some of the integrations, right? I mean, even I am doing this first time with all of you as I'm moving forward. Let's create a phone number for it to work with. Let me create this phone number. Let me display a name. Can choose languages. Save. I have a phone number. Let me try calling this phone number from my mobile and see if this works. 1880.
Dial number does not exist.
Unfortunately, it's blocking my Indian phone to call this number. But typically, what happens is if you call this number, the agent is suddenly live, right? So, and there are other native integrations that you can do out of the box. Like we can try connecting it to a Google chat. Let's see. Uh, have to give it out a lot of permissions. I do not have any other chats, but yes, these are all the out of the box integrations that you can connect to any messengers, right? So you can have it integrated in your conversational message. I mean, just use this script into any website, and you see here we have this bot coming to live, right? So this was our on the right side, this was our testing ground, but now we have this bot live here. So I'm just doing random crazy stuff with it. And you see if I'm just switching topics just like humans, right? It gets you back on track. It says, would you like discussing your blood pressure to assist you? Yes, and let's just explore it a bit. No other health conditions. R100, some things. It's asking me further questions to understand more about me, just like a normal doctor would. No medicines, just pain, and I do not exercise. Right, so it says strongly recommend that you consult a doctor as soon as possible. Could further asks, I stay in Bangalore with pin code, which is the nearest hospital. Unfortunately, it's not yet built to identify hospitals. Can you suggest, or are you not trained for it? It says I'm not trained to provide real-time hospitals, but essentially we can go back to our playbook and make changes to this. So, uh, a quick short demo of, I think we literally built 5 or 6 agents in what say 30-40 minutes. So this is called as conversational agents, where you can define a lot of your agent, use real time. I mean, instead of codes, just use our aptitude, right, and use instructions to get this going and build our first conversational agent. You can then have your test cases, your histories. We can build uh, agents in different languages. Let me even show that. So let's create an agent in with default language as Hindi or French or Irish. What I just say. Create. uh, But just say your task is to be a medical officer and search hospitals for me based on a user's PIN code. Just start with the user and ask what condition he has. Basis that ask his geolocation, city or PIN code, and suggest nearby hospitals. So as small as this, let's just save. Let's test this agent. Let me say hi. It says I'm here to help you find hospitals. Can you talk in Hindi? And you see, we created a multilingual bot literally in seconds, where we chose Hindi as a language and it started in Hindi, and it even understands multilingual, right? So typing Hindi in English, and I'll just say and see it says अब बेंगलोर में और आपका पिन कोड है, लेकिन आपने अभी तक मुझे ये नहीं बताया कि आपको क्या. Sorry, my Hindi is really bad, but basically I'll just tell I am feeling chest pain. It says switch back to English, right? And this is how literally with just 2-3 lines of instructions we can build real-time agents, right? And the deployment mechanism is so easy that all you need to do is go to integrations, choose any one of the integrations. For example, if you want a conversational messenger on your website, right? So we see this button appearing here, a completely Hindi bot which says, so this we have built this bot. We have built this bot in literally seconds and deployed it on a website. Uh, this was something fancy that I wanted to show all of you as a demo. Um, any questions? Happy to answer. Unfortunately, I'm not able to see the chats.
Yes, sir, we have one question in the chat box.
Yeah.
For creating this type of agent creation, we do not have to pay any API keys.
No, so so API keys are a different concept, right? Okay, so what we did here is we have not. Okay, so how when will we use API keys typically is when we are using a SaaS product, a software as a service, right? Meaning we are using somebody else's model. We are using a OpenAI model. And for my application to integrate with an OpenAI model, OpenAI gives me a key and it says, authenticate using this key, right? And that is how typically API keys are used for monetization, one, and for authentication. But in this case, we are not using a default model, we are building our own agent. So what we did literally is we didn't build an application, right? We built all these machine learning models. So we created 7 agents of ourselves. Now we are the service providers, so we will be the ones exposing this model, right? So in that case, so let's say if you want to deploy it, if you want to if you want uh, a caller or a third party application to authenticate APIs with you, you can use this, right? Saying that authenticate API with a third party identity provider, and we can give an identity provider like a ForgeRock or a Azure AD or any of these general third party authenticators or Google Identity. Or in this case, what I demoed was a unauthenticated API, right? And just popped up. So basically, essentially, we are the service providers here. So we are creating models, but we can safeguard these models using API keys and other monetization mechanisms or authentication mechanisms. Um, I hope that answered your question. Else, I think Rahul was asking whether the AI works on phone. It does work on phone. A billing account is needed to use these tools. Yes, Rahul. So generally, a billing account is needed to use these tools. But with Google, you can explore, right? So you get 25,000 rupees of free credit on your first login. So this is a great playground where you can basically explore any of the machine learning models that you want to build. So there is 3 months and 25,000 rupees free credit that Google gives you to experiment with their AI models.
Dear participants, do you have any queries? Thank you for the wonderful session, sir. Now I call Sushmita ma'am to deliver vote of thanks.
Thank you, ma'am. We extend our sincere gratitude to Mr. Shreyas Hegde for delivering an enlightening session on machine learning for healthcare analytics and for demonstrating practical applications on machine learning in healthcare. The session was highly informative and offered deep insights into how artificial intelligence and data analytics can contribute to achieving sustainable development goals. The practical demonstrations showcase the transformative potential of machine learning in areas such as disease prediction, patient care, and medical decision making. The participants gained valuable exposure to emerging tools and techniques in generative AI and agentive AI that bridge the gap between technology and healthcare solution. We truly appreciate your time, effort, and expertise in making this session a success, and we look forward to future collaborations that will continue to inspire and benefit our academic community. Thank you, sir.
Thank you. Thanks for your time, everyone.
Thank you, Shreyas. Thank you very much. And participants, thank you very much for this patience listening. And tomorrow we will start the session by 6:30 once again. Thank you.